Greetings. This is Ezhilarasu, Assistant Professor, PG and Research Department of Physics, Bishop Heber College. In this video, I am going to discuss about Chuas diode. Chuas diode circuit and its characteristics. In electronics and circuit theory, Chuas diode is a type of two-terminal nonlinear active resistor which can be described with piecewise linear equations. It is an essential part of Chuas circuit, a simple electronic oscillator circuit which exhibits chaotic oscillations and widely used as an example for a chaotic system. It is implemented as a voltage controlled nonlinear negative resistor. The diode is not sold commercially and it is usually built from standard circuit components such as resistor and operational amplifiers. There are many ways to simulate Chuas diode using such components. Chuas diode was invented by Leon Chua, who is also the inventor of Chuas circuit in the year 1983. Before going to see the diode design, we have to know a little bit about the operational amplifier. The operational amplifier is an extremely versatile and inexpensive semiconductor device which has become the workhorse of the communication, control, and instrumentation industry. The schematic of the operational amplifier is shown here and its transfer characteristics also shown here. Here we gave two schematics. One is ideal characteristics and another one is practical characteristics. The transfer characteristics is an odd symmetric curve containing three distinct regions. One is linear negative conductance region. Second one is positive saturation region. And third one is negative saturation region. The ideal operational amplifier transfer characteristics can be approximated in the given figure. The equivalent circuit of an operational amplifier for a linear negative region. This is the linear negative region representation and the positive saturation region and this is the negative saturation region. In the linear region, the output voltage of the operational amplifier satisfies the inequality called as the validating inequality. The equation of the validating inequality is given here, that is minus saturation less than V of t less than E saturation. Negative impedance converter. A negative impedance converter is a good example of a circuit having a piecewise smooth characteristic. It consists of an operational amplifier incorporating both positive feedback via R2 and a negative feedback via R1. The circuit of a negative impedance converter shown here, its characteristics shown here. Positive saturation region. By applying Kirchhoff's current law to the node 1 shown in this circuit, this is node 1, node 2, node 3, node 0. So by applying Kirchhoff's current law to the node 1, the current in this region I is equal to 1 by R into V minus V out. V is the input voltage and V out is the output voltage of the operational amplifier. By applying Kirchhoff's voltage law to the loop 1301 and the amplification factor A being large, the voltage in this region V greater than or equal to R3 divided by R2 plus R3 into positive saturation plus V offset. For the validating equation, the breakpoint is obtained as Bp is equal to R3 divided by R2 plus R3 into positive E saturation plus offset voltage. The slope of the characteristics in this region is M01 is equal to 1 by R1.
negative saturation region. The current in this region is defined by I is equal to 1 by R1 into V minus V out. The voltage in this region can be given as minus V less than or equal to minus R3 divided by R2 plus R3 into negative saturation minus V offset. From the validating equation, the breakpoint is obtained as Bp is equal to minus R3 divided by R2 plus R3 into negative saturation minus offset. The slope of the characteristics in this region is M01 is equal to 1 by R1. Linear negative conductance region. Under conditions of large amplification and applying Kirchhoff's laws, the current and the voltage in this region are given as I is equal to minus R2 divided by R1 R3 into V plus R2 plus R3 divided by R1 plus R3 into V offset. And the slope of the characteristics is M11 is equal to minus R2 divided by R1 R3. Here Vos is the offset voltage for the operational amplifier. The slopes and breakpoints of this piecewise linear characteristics agree well with the experimentally obtained values. Chuas diode. The Chuas diode is a two-terminal nonlinear resistive element having a piecewise continuous odd symmetric voltage current characteristics and is synthesized using operational amplifier and a resistor. It can be constructed by connecting two negative impedance converter in parallel. The figure shows the Chuas diode circuit realization using two parallel negative impedance converters. The parameter of the first negative impedance converter can be given as M01 is equal to 1 by R1 and M11 is equal to minus 1 by R3. The breakpoint BP1 is equal to plus or minus R3 divided by R2 plus R3 into E saturation. Similarly, the parameters for second negative conductance are M02 is equal to 1 by R4, M12 is equal to 1 by R6, the breakpoint BP2 is equal to plus or minus R6 divided by R5 plus R6 into E saturation. By proper selection of parameter values, we can choose the characteristics of both the negative conductance to have different slopes and breakpoints as are shown in the figure. The compound characteristics for the Chuas diode as a whole, the values of the slopes are calculated as M01 plus M02 is equal to M0 and M11 plus M12 is equal to M1, where M0 is equal to minus 1 by R3 plus 1 by R4, M1 is equal to minus 1 by R3 minus 1 by R6. The full superimposed piecewise continuous characteristics of the Chuas diode. The characteristics can be defined mathematically by the functional relation I is equal to M1V plus 1 by 2 into M0 minus M1 into modulus of V plus BP minus modulus of V minus BP. This is the another mathematical representation of the same curve, and by taking the experimental data from the laboratory, we plot the characteristic curve and we estimated the M0 and M1 and BP values. Here M0 is equal to minus 0.409 millisiemens, M1 is equal to minus 0.765 millisiemens, BP2 1.08 volt. So these are the values we choose for two operational amplifiers. For first NIC, we have choose R1, R2, R3, the values 220 ohm, 220 ohm and 2.2K. And for the next NIC, 22K, 22K, 3.3K. And we used the operational amplifier mu A741, or we can choose TL081. So this is the CRO captured characteristic curve. This Chua diode is used to construct Chua's oscillator and Murli-Lachmann-Chua's oscillator, and so on. In the next video, I will going to present Murli-Lachmann-Chua circuit. Thank you for watching.